is are these extraordinarily dense zones under the Maria that are so that are so strong that they actually deflect. In the early days, they were when the lunar orbiters would fly over a mascon, they would actually be deflected in their orbit because of this something really strong under the surface of the center of the mascon.
Have they mapped those? Do they have you seen a map of them? Do they look does it look fake or organic?
No. I've mapped them. I mean, I haven't mapped them, but I have showing the maps of the mascons. I've got it in my 329 slideshow, right? Okay, so
are they all on the same side?
Are they all on the same? Most of them are on the near side because most of the mascons are on the near side, right? There's one mascon, I think, on the moon's far side. And I'm trying to remember if there's a mascon. Most of the Maria have these mascons under them. And again, I wasn't really necessarily prepared to get into that. But if you wanted to, I could get it set up. We could take a little break or something, and then we could come back to that. But we were going to focus more on the eclipse. Where am I here? Come on, damn it. Slide 29, 30. Okay, do you want to, hey, well, since I've got it right here, you want to do share screen?
Yep.
Yeah, let's do it.
Okay. So this is a lunar gravity map, and the contour lines show the gravity strength above the mean value of moon in units of 100 milligals.
I think you got to click on it still. We don't see it yet. Yeah.
Can you see it now?
No.
I can't see. You got to click present again.
Oh, right. Of course. Yeah, sorry. Share screen. Share screen. Should be the same window, but I got to select it again. Screen 2. Yeah, there we go. You getting it now?
Yep,
we got it.
Okay, so these are these extremely dense regions underlying the lunar surface, mass concentrations. And this is the near side Maria, which are the big, the seas, the dark blotches. When we look at the moon and we see the man in the moon face, that's because of the Maria that we're seeing, right? So the Maria, all of the near side Maria have these gigantic, we don't know how big they are, but whatever they are, they're extremely massive and extremely dense. And that's an anomaly. The reason it's an anomaly is because they are so much more dense than the surrounding material would be implied, that they should have eons ago sunk to the center of the moon. Just like if you put a little lead pellet on the top of a surface of a bowl of Jell-O. What's going to happen? It's not going to drop. It, of course, depends on the viscosity. You put that lead pellet, and if it's water, it's going to go really fast to the bottom of the bowl. If it's
yogurt,
it's going to go right. If it's Jell-O, it may take a couple of hours, but it's going to sink through. Now if you took a green pea and put on there, it probably wouldn't sink, right? But the lead pellet would sink.
So is this a density then, or what is that brown dot then?
It's density. That's exactly what it is. And let's see here if I got something. So here's another, vertical acceleration at the lunar surface for the LP165P gravity field. Acceleration of the radial component at the lunar surface sphere with radius 1738.0 kilometers. So 1738 kilometers times 1.62. Okay, so the near side on the left includes coefficient to degrees and order 110. We don't need to explain all that, but this is again showing these large density anomalies. Here we can look at this quote: "The discovery by Muller and Sogren of mascons in the moon is of great interest. My investigations allow a calculation to be made of the size and depth of the mascons in terms of the size of the mare formed by low velocity impact of an iron meteorite. Now, the problem with that theory early on is that at whatever velocity you bring that collision to occur between meteorite and the lunar, the meteorite is going to basically vaporize. So I am currently completing an analysis of penetration and cratering of concrete and soils by steel projectiles. He goes on, let's see here.
Yeah, but even if it vaporizes, wouldn't it just maybe push or squash it all together to concentrate the mass somewhere?
Probably. So these results suggest that the lava-filled maria were formed when very large iron objects struck the surface of the moon at a velocity so low that there was no immediate fracture of the object.